Hey, I'm RKI3000 and what you're seeing right now is my Flappy Bird X breakout video game. You play as a bird with Flappy Bird controls that hops around breaking all kinds of blocks and avoiding pipes. Last time we left off with a bird, a modular pipe system, and basic block functionality. But what I didn't tell you last time is that the project is a complete and utter mess. I was using Godot 3, but I was also aiming to switch over to Godot 4 due to its improved functionality. So I took the opportunity to completely revamp the project. In this devlog, I'll show you how I did that, but also how I made new kinds of blocks, charged abilities, a fatigue system, and very
wiggly jiggly pipes.
Okay, so let's start with the wiggly pipes, since I added them before the project overhaul. The way that the pipes work in the game is that I have a pipe manager that dynamically spawns different pipe pieces. For example, you can see a pipe end here and a pipe block. It's super modular and I talked about it a lot in my last devlog, but the problem was that if I wanted to change the path of the pipe, then this happened. You could clearly see the seams between each pipe piece. The solution to that was
wiggly jiggly pipe.
For example, let's take these two pipe ends. We want to get rid of the seam. To do that, we define their corners, add a sprite that has its corners match, and there we go.
Wiggly jiggly pipes.
In reality, it was a bit more complicated. At first, I tried warping the sprite using a shader, which turned out to be a total nightmare. You can even see it here. I had a bunch of control points that I could move around in the scene, updating the shape directly in the game in real time. I was pretty proud of this too because I had basically reinvented a Polygon 2D node from scratch. But you know what I could have done instead of spending all of that time on weird shader hacks? Yeah, just have used the Polygon 2D node with texture in the first place. Godot literally has that built in, I just forgot it existed. So yeah, I remade the whole system twice, once with the sprites and once with the much better Polygon 2D node, and you can't even see the difference. However, the final result is silky smooth and I don't even have to worry about that anymore. And if I color the polygons blue, you can more clearly see how the system of the wiggly pipes works. This is around the time that I decided to move the project to Godot 4. The cool thing is that Godot automatically converts your scripts and other files to account for some of the new Godot 4 quirks, like changing exports to at exports and all that. So technically I could just open the project and have it work. But it wasn't that simple. A bunch of stuff still broke, and you know what they say, if it ain't broke, don't fix it. However, it was broken, so I had to fix it. So I did what any normal person would do in that situation, and I rewrote the entire structure of the project. Originally, everything was built using inheritance. Inheritance is an object-oriented structure, where you have a base class and everything else just extends from that. For example, in my case, I had a base block scene. This one block handled basic stuff like detecting collisions, braking, and doing some visual effects. Then every other block, pass-through blocks, rock blocks, future crazy ones, just inherited from this one scene and modified a couple of things. Sounds clean, right? Except it wasn't. Every time I wanted to make a new type of block, I had to either override a ton of stuff or add a bunch of if statements into the base class, which means that it got messy really fast. So I switched to another approach, which is called composition, and here's how that works. Instead of one big block class that does everything, I now have smaller reusable custom components that I can combine to make a block. For example, in my block scene over here, a health component handles how much damage something takes before breaking. A solid component just defines if something is solid or pass-through. A hit flash component makes the object flash when hit. A particle component spawns a particle effect on impact. There are way more components, but you get the idea, and now it's super easy to just make all kinds of blocks, and they will all be independent from each other. This approach is way more modular, scalable, and honestly, way cleaner to look at. This also means that I can reuse those same components in other objects, not just blocks, like maybe enemies or interactive tiles, or even the player. I'm basically building a little toolbox of behaviors that I can plug into anything. Heck, now if I want to make a wall that sparkles, I can just mix and match all of the different components together, and it's super easy to do. Since we're talking about blocks, let me show you some changes I made to them. This is what they looked like in the last devlog. Back then, I just decided to copy the ones from Breakout, with their rectangular shape. However, I realized that the blocks from Breakout are shaped the way they are for a reason. The larger area on the bottom allows the ball to more easily hit them, and the smaller area on the sides allows the ball to hit multiple blocks at once from many angles. However, in my game, where the bird can essentially move in any direction, This makes less sense, since you will be breaking blocks from the side as often as on the bottom and on the top. I therefore switch from a rectangular to a square design for the blocks. Now, let's cover all of the blocks that are in the game. The basic blocks, sturdy and solid, can be broken in one hit. The pass-through blocks, which aren't solid, can be easily destroyed. Now here are the more interesting blocks. The rock block functions like a basic block, but takes 2 hits before being destroyed. First you break the rock shell, then the inner block is exposed. The vine block is indestructible and latches onto other blocks. It can only be destroyed by destroying a block adjacent to it. Here's how that looks in game. And finally, mushroom blocks remove the solid property from a block, like the pass-through blocks, and they also spread onto adjacent blocks. This makes it super easy to clear large clumps of blocks, as you can see here. And funny thing, the last 3 blocks I talked about are made out of rock, vine and mushroom components. That's how I add the mushroom property to the blocks. I just check for adjacent block when it gets destroyed, and then I add the mushroom component to them, regardless of their type. This also allows for some neat interactions already, like between the mushrooms and the vine blocks. Maybe I could even make an enemy that aims and shoots projectiles that change block properties. Another improvement that came with this overhaul was the implementation of state machines, notably for the player. Instead of cramming all of the logic into one big script of 100 if statements, each state, like idle, jumping, or falling, has its own script that handles what it should do. This made the code way easier to manage, and only one state can run at a time. Plus, it makes it super easy to add new abilities. The abilities work in a very simple way. You charge them up by pressing a key, which charges up the ability. Then, when it's charged, you let go of said key, doing the ability. Different keys correspond to different abilities. Here's what they look like in game. The yellow circle corresponds to the jump ability, which has the quirk of you not being able to jump while charging it. The blue circle corresponds to the dive ability. And finally, the green circle corresponds to the charge dash ability. I have a plan to make a system where you can mix and match these abilities, sort of like charms in Hollow Knight. The abilities also allow you to easily smash through blocks, which is super satisfying, and it is indicated by the spinning animation. Code-wise, I have another state machine that handles all of the charging logic, which allows the player to simultaneously charge and jump, for example. Then when you let go of the key that lets you charge the ability, I just tell the other state machine to transition to the state, making things very streamlined and scalable. Finally, you may have noticed that if the bird jumps too much, it will get fatigued. This is the new stamina system that makes the bird more and more tired as you jump, limiting the maximum height you can reach. This makes the bird less overpowered, since with true Flappy Bird controls, you can just fly over every obstacle and flap infinitely. It also allows for more control in practice and actually gives a purpose to some of the abilities. In fact, I didn't mention this yet, but the charged jump removes your fatigue, so you can actually, if you're skilled enough, jump infinitely. It's just that it's more engaging than just mashing the jump button. There, that's all I've done in the last 6 months. Well, with school projects, releasing a devlog for a jam game and participating in the Nordic Game Jam and more, I had and still have a lot to do, so I didn't work on the project that much. As for my plans for the project, I plan to add the charm system for the abilities I talked about earlier, and I have a great idea for it, and I think it'll be one of the strong suits of the game, so stay tuned for that. I also want to clearly outline the game loop, which consists of going into levels one after the other, Mario style. I have so many ideas for this game, as you can see on these paper sketches, I have a lot of them, and I definitely think it has some really big potential. I also want to thank all of you for the views on the last video that kind of blew up with 2,000 views. It's cool to see that people are interested in the things that I make. But with that, if you have a comment, suggestion or anything to say really, leave it in the comments, because I read and reply to every single one. Feel free to also join my Discord server, where I post small updates about my game, and I can talk with you all. The link is in the description. Thanks for watching, and see you in the next one.
Wiggly jiggly pipes, widgily.